Hello students, welcome to Go Vidya and welcome back to the 1000 important series questions. Today we will discuss about the DC machine questions. So let's move to the first question. A DC shunt generator is delivering 20 kilowatts at a terminal voltage of 200 volts to a resistive load. The armature and shunt resistance are 0.5 ohm and 100 ohm respectively. Calculate the induced EMF in the armature. So we have to calculate the induced EMF in the armature. So in the question they have given the armature resistance and the shunt resistance, nothing but RA and RSH, and terminal voltage VT they have given in the question, and power they have given, but they didn't give any current. So from the power we have to calculate the current, and the generator they have given is that is known as DC shunt generator. So we'll draw first the DC generator. So this is the terminal voltage VT. So this is RA and this is EG, generated EMF in the generator, and this is IF, ISH or RSH, IF, ISH, RF or RSH, and this is the load current and this is the armature current. From this circuit diagram I can write that IA is equal to IL plus, just applying the KVL, plus ISH or IF. In the question they didn't mention anything about the current. We have to find the current. See, we can find the current by, they have given P is equal to 20 kilowatts and VT is equal to 200 volts. From this we will calculate the IL. We know the formula, P by VT, that is 20 kilowatts, nothing but 20 into 10 cube by VT is 200. So we can write 10 kilowatt, that is 1000, 2, and so we will get around 100. IL is 100 amperes. So in the question they have given about the RSH also. So I can find from the data ISH. So ISH is equal to VT by RSH. So VT is 200 and RSH is 100. So we will get 2 amperes. From this we can calculate IA is equal to IL plus ISH, which is nothing but 100 plus 2, 102 amperes. So we have found the current. Now we have to know what is the formula of the induced EMF, nothing but the generated EMF in the DC shunt. So that is equal to, EG is equal to VT plus IA RA. And in this question they have said that neglect the brush voltage. So actually plus VB, but we have to neglect the brush voltage. Now VT is 200 plus 104 into armature resistance is 0.5. Armature resistance is 0.5. So we will get 200.5, we will get around 251 volts. EG is equal to. So the generated EMF, the induced EMF in the DC shunt generator is 251 volts. 251 volts. Clear? Let's move to the next question. An 8-pole DC generator has a simplex wave wound armature containing 32 coils of 6 turns each. Its flux per pole is 0.06 Weber. The machine running at 250 RPM. The induced armature voltage is, nothing but they are asking the induced armature voltage, but the data given is flux they have given, speed they have given. They didn't give the direct conductors, but they have given 32 coils of 6 turns. So we have to find the number of conductors, and the winding is wave winding. So coming to the wave winding, we'll learn some of the basics. Wave winding, the number of parallel paths will be always 2. Clear? For the lap winding, the number of parallel paths will be equal to number of poles. Wave winding is used for high voltage, low current. High voltage and low current. Coming to the lap winding, they use for low voltage, high current. Okay, so these are some of the basics you have to know about the wave and the lap winding, and one more important is power will be same whether it is a lap or wave winding. So clear? So let's solve this problem. So we have to calculate the induced EMF. We know the formula Eg is equal to Zn phi by 60 into P by A. Clear? But they didn't mention the conductors. How to do the conductors? They have given 32 coils, nothing but 32 coils into 6 turns into 2. We will get around 12, 32 12 is nothing but 384. So we will get 384 conductors. So all the data is present. So just we will substitute in the formula. Eg is equal to 384 conductors into speed is 250 rpm and the flux is 0.06 Webers by 60 into, so the number of poles are 8 poles, and A is nothing but the number of parallel paths. As in the question they have given the wave winding, so number of parallel paths will be is equal to 2. If it is a lap, we have to substitute the number of parallel paths will be number of poles. If you solve this equation, we will get around 384 volts. E.g., the induced EMF or generated EMF will get around 384 volts. Clear? So let's move to the next question. A differential compound DC generator has its series and shunt field, providing 20% and 80% flux respectively. So for the series and the shunt flux, field flux they have given, that is 20 and 80%. The series field is suddenly short circuited. The series field is suddenly short circuited without changing the load. Then the terminal voltage ignoring all the resistance. So this very simple. In the initial, let's consider the two cases. In the first case, they have given the series and the shunt field resistance, that is 20 and 80. In the case 2, they are saying that suddenly it has been short circuited. The series field has been short circuited. Then we have to find the difference of the case 1 and the case 2. If you see the diagram of differential compound, I am not very good at diagrams. So we have to draw the shunt and series. So this is the series. This is phi SC. This is the series flux. This is the shunt flux. And this is the shunt MMF. And this is the series MMF. So here in this we are taking the difference of both the shunt and the series. Clear? So I can write total MMF. Total MMF is equal to, this is the difference of the both shunt and the series. So I can write shunt MMF minus series MMF. So this is the basic thing you have to know about the differential compound DC generator. So now let's solve the problem. So we will take the two cases and we will solve by taking the two cases. In the first case they are saying the phi SH will be 80%. 80 means we can take 0.8. Series is 20%, which is 0.2. Now differential compound is nothing but the difference of the shunt and the series. So if it see that, I will take as E1. Phi SH is 0.8 minus 0.2. So we will get E1 is directly proportional to 0.6. So this is the case 1. If you observe the case 2, In the case 2, they have given that series field is suddenly short circuited. Nothing but, can I take phi SC is equal to 0? Yes. As suddenly short circuited, I can take phi SC is equal to 0. Now we will substitute. E is directly proportional to, again, phi SH minus phi SE. Now this phi SC will become 0 because it is suddenly short circuited. So I can write E is directly proportional to phi SH, which is nothing but E is directly proportional to 0.8. Now we have to take the difference of this case 2 and the case 1. If we take the difference, we will get E is directly proportional to 0.8 minus 0.6, which is nothing but 0.2. So 0.2 is nothing but 20%. So it increases by 20%. So here the option C matches. Clear? It increases by 20%. A 4-pole separately excited wave-wound DC machine with negligible armature resistance is rated for 230 volts and 5 kilowatts at a speed of 1200 rpm. If the same armature coils are reconnected to form a lap winding, what is the rated voltage and the power respectively at 1200 rpm of the reconnected machine? As the question is very lengthy, but the content in that, the data in that is very simple. See, the machine is connected in the wave. With the same data, they have connected the machine into the lap winding. Now we have to find what is the lap winding voltage. Clear? And the power. So before calculating the voltage, already I have said that for a lap or the wave winding, whatever the winding may be, the power will be constant. So the power given is 5 kilowatts. So now the power will be 5 kilowatts. So let's check in the option once 5 kilowatts is present or not. For the A option, this is wrong, this is wrong. So for B. So let's check for the A and B options right now. Clear? Now, see, also we have said for a lap winding we have the low voltage. So we'll check whether we'll get, because for a wave winding we got 230 volts, we'll check for the lap winding we'll get the low voltage or not. For a wave winding we have the high voltage. See, I'll tell a simple shortcut how to remember. The lap winding is a low voltage, for a lap L, and for the low voltage L. So definitely for a lap L, for a low LL. So you remember only one, automatically you can remember the other one also. Don't by heart, just make sure of one, then the other will be automatically come into the picture. Clear? Now we'll find the voltage of the lap winding. We'll do that. So we know the formula in general, Eg is equal to Zn phi by 60 into T by A. Yes or not? See, the machine is already constructed, done. If it is constructed, we cannot change the conductors. The speed is constant for both the lap and the wave. Flux I cannot change right now. So poles also I cannot change. So all these parameters are the constant. So the remaining is only 1 by A. Yes or not? So can I write Eg is directly proportional to 1 by A, or Eg is inversely proportional to A? A is nothing but the parallel paths. Now what I do is E lap by E wave is equal to A wave by A lap. Clear? Now I have to find the E wave winding of the EMF induced. So what is the E lap voltage they have given? 230 volts. So 230 by EW is equal to, for the wave winding, number of parallel paths will be always 2. For the lap winding, number of parallel paths will be always number of poles. So they have given the 4 poles. So this is 2. So we will get EW is equal to 115 volts. Clear? Next, so the option B matches. Clear? So we have to solve, if a problem they have given, you have to solve like this. And remember, for a lap, low. Clear? Automatically for a wave, high voltage will be. Next question. A DC shunt motor draws an armature current of IA amperes under normal rated conditions. And for a constant power output, if both the flux and armature terminals are halved, the current will be. See, in the case 1, that is under normal rated condition, the current IA they have given. But in the second case, they are saying that terminal voltage and the flux has been halved. What is the value of the current? So simple, we have to find what is the value of the current, but the given motor is DC shunt motor. So for a DC shunt motor, we know EB is equal to VT minus IARA. From this IA I can write as VT minus EB by RA. And the question they have given both the flux and the armature terminal voltage, which is nothing but EB. EB is equal to V by 2 and the flux phi is equal to phi by 2. Let's substitute in the armature current value, we will get IA is equal to V minus V by 2 by RA, which is nothing but 2V minus V by 2RA. So we will get around V by 2RA. IA is equal to V by 2RA. So V by RA is nothing but, can I write V by RA is equal to 2 into IA. So the current will be approximately 2 into IA. So the option C matches. Clear? A 100 volt separately excited DC generator supplying 10 amperes at a load. The armature resistance is 0.5 ohm. If it is operated as a motor at the same excitation on some current and the voltage, the ratio of motor to generator. See, nothing but a separately excited DC generator. At the first, it is acting like a generator and the motor. So now what we have to do is, in simple is, let's find the induced EMF for both the generator and the motor and we'll do the ratio. That's all. We'll find the generated EMF of the generator and the back EMF on the motor and we'll do the ratio. So the generated EMF for the generator is VT plus IARA. So in the equation, VT is 100 plus 10 amperes. So 10 into 0.5, you will get around 10 into 5, you will get around 105. So this is for generator. Coming to the motor, we know the formula EB is equal to VT minus IARA. So VT is 200 minus same 10 into 0.5, you will get around 95. So now we have to do the ratio of motor to generator. So simple, we know some of the performance basic equations. We will see that EB or EB is equal, EG is equal to KA phi omega. This is one of the most important performance equation, and the second equation is with respect to torque. TE is equal to KA phi IA. Now let's, with the help of the first performance equation, I can write EG directly proportional to phi omega. Now I have to find the ratio of the motor and generator. So from this, can I write EG by EM by phi 1 by phi 2 or phi generated by phi motor into phi generated by phi motor into N generator by N motor. So simple, I have to calculate the N motor by N generator, which is nothing but flux is constant. So what is the value of the motor? 95 by 105. Nearly I will get around 0.9. So 0.9. So the option B matches. Clear? These performance equations are very important. We solve all the problems with the help of these performance equation, where EG is equal to Ka phi omega and TE is equal to Ka phi Ia, and one more formula, PG is equal to EB into Ia, that is equal to TE into omega. These three performance equations plays a crucial role for doing the problems, for solving the problems. Clear? These are very important equations. So let's move to the next question. A 4-pole 4 kilowatts 200 volts lab connected DC generator running at 1000 rpm. For the same speed, the excitation, if the winding reconnected to wave, its current rating will be. Its current, we have to calculate the current rating. So in the previous question, if we observe the previous question, if we check the previous question, for the wave winding we got 230 volts. For the wave winding we got 230 volts. For the lab winding we have got 150. 230 is given in the question. I already said for a lab winding definitely a low voltage should come. Yes or not? So in that way we have got the very low voltage, that is 150, with compared to the wave winding, that is 230 volts. Clear? So now we have to calculate the current when it is connected to the wave. So we will find that. So we know the formula, Eg is equal to Zn phi by 60 into P by A. So I will tell a simple formula for you. We have to find the wave current. So I will say the lab current by, so before finding the lab current, I have to, before substituting the lab current here, I have to know the current value. How can I calculate? Because the power is given, the voltage is given, so I can calculate the current. I is equal to 4 kilowatts, so I can write 4000 by 200 volts. I will get 20 amperes. So I will get 20 amperes. So I wave is equal to lab current by lab paths into wave paths. This is one of the formula we can use for finding the wave current directly. So wave current is equal to lab current by lab paths into wave paths. So what is the lab current? 20. Lab paths is nothing but, in the lab number of parallel paths will be number of poles, that is 4, into wave paths. In a wave winding, number of parallel paths will be equal to 2. So we will get around 10 amperes. Yeah. Now I got how much ampere? 10 ampere. Again, for a lab winding we have the low voltage, high current. Coming to the wave winding, we have high voltage, low current. If you observe, for the lab winding we have generated 20 amperes. For the wave winding we have got around 10 amperes. So is this looking similar to this data? Yes. So lab winding will have the low voltage with high current, and wave winding will have the high voltage with the low current. So the answer 10 amperes. So option C matches. Next question. A DC shunt generator producing 200 volts at a speed of 1200 rpm. If the speed reduces to 1000 rpm with a constant excitation, then the EMF induced is. So nothing but the speed has been reduced from 1200 to 1000 rpm. So we have to calculate the E2 speed. So from the performance basic equation, and the given generator is DC shunt generator. So the performance equation is EB directly proportional to phi omega. So EB1 by, they have given the generator, so I have to write EG. If it's a motor, we have to write the back induced EMF EB. So EB is equal to EG I will write like E1 by E2 is equal to phi1 by phi2 into N1 by N2. But in the question they have given a same excitation, constant excitation. So the flux is the constant here. Flux is constant, so E1 by E2 is equal to N1 by N2. So I have to calculate the E2 value. So I will reciprocal it. E2 by E1 is equal to N2 by N1. Now E2 is equal to N2 is 1000 rpm. From 1200 to 1000 rpm it has been reduced. So I will take as this is N2, this is N2, this is N1. Clear? So 1200 into what is the value of E1? 200 volts. So this is 6000 by 6, which is nothing but I will get around 166.7 volts. E2 is equal to 166.7 volts. Clear? So I have solved this problem by using the performance basic equation, which is very important. So next question. If the speed of DC generator increases, then its critical resistance value. They are saying that speed of DC generator increases, what is the critical resistance value? So it's very simple. R critical is directly proportional to omega critical, nothing but directly proportional. Here the speed increases. When the speed increases, automatically the resistance also will increase because directly proportional. Very important. Clear? So the answer will be D. Clear? Next question. A DC motor running in steady state draws an armature current of 30 amperes. To develop the same torque at the armature current of 45 amperes, the flux should be. So we have to calculate the flux, and they are saying that the current has been, the torque has been same torque. The torque is same, but the current is changing from 30 to 45 amperes, and the type of, they have given the DC motor. They have given the DC motor. So by using the performance equation, I can calculate the value of the flux. I know the formula T is equal to Ka phi Ia. Now T is directly proportional to phi Ia. Now in the question they are saying that the same torque, nothing but in the both the cases the torque is same. Can I take the torque as a constant value? Yes, I can take as a constant. If I consider the torque is constant, now flux will be inversely proportional to armature current. Yes or not? Flux is inversely proportional to armature current. From this I can write phi 1 by phi 2 is equal to Ia2 by Ia1. But I have to calculate the flux. So phi 2 by phi 1 is equal to Ia1 by Ia2. So the value of Ia1 given as 30 amperes. 30 by, now 30 amperes has been changed to 45 in the second case. So 15 2s, 15 3s, 2 by 3. So 2 by 3, which is nothing but 66.66%. So can I say 66.66%? So nothing but it will be reduced by 66.66%. Flux will be reduced by 66.66%. So the answer is C. Clear? So if I know the performance equations, I can solve the problem. Yes or not? So I have used the performance equation, that is T is equal to Ka into phi Ia. Next question. A separately excited DC motor supplied from 300 volts drawing 100 amperes to drive a 300 Newton meter load, and Ra is equal to 1 ohm, the speed of the motor in radians per second. So we have to calculate the speed. They have given the data: current, torque, armature resistance and the voltage, the speed of the motor. So to solve this problem, if I use EB is equal to, it is a motor, Vt minus IaRa, but I have to calculate the speed. So by this formula I cannot. So EB is directly proportional to phi omega, but in the question they have given the torque. So this is the, by using this equation also I cannot calculate. So by using one of the performance equation I can calculate it. That is EB into Ia is equal to Te into omega. So Pg is equal to, actual the formula, Pg is equal to EB into Ia is equal to Te into omega. What is the EB given in the question? 300 volts. 300 into, what is the armature current? 100 amperes. The torque 300 into omega. So I have to calculate the omega. The speed is nothing but I have to calculate the omega. So if we substitute 300, before calculating the EB, they have given in the question Vt. So EB is equal to Vt minus IaRa, which is nothing but Vt is 300 minus Ia is 100 into Ra is 1 ohm. We will get around 200 volts EB. Sorry, in the question they have given the terminal voltage, not the back EMF. So now we will substitute in this question. The EB I got here is 200. So 200 into Ia is 100 and torque is 300 into omega. If you substitute, you will get 200 by 3. Yes or not? 200 by 3, which is nothing but we'll get around 66.66 radians per second. Approximately I will take as 67 radians per second, the value of omega. Clear? So by using the performance basic equation, I have found the value of the omega. In the question they have given the terminal voltage Vt. Clear? Next question. A DC series motor drawing 100 amperes and driving a load torque of 900 Newton meter. Now the load torque is increased to 1800 Newton meter. The magnitude of current will be. See, now in the question, the current they have given, they are saying the torque from 900 to 1800 it has been increased. The type of motor they have given as DC series motor. So let's calculate the current. They have given which motor? DC series motor. Yes, we know the formula T is equal to Ka phi Ia, which is nothing but T is directly proportional to phi into Ia. In DC series motor, we know flux is directly proportional to Ia. Yes or not? So substituting we will get T is directly proportional to Ia into Ia, which is nothing but T is directly proportional to Ia square. So in this equation, let's substitute the values and we'll find the current value. From this I can write T1 by T2 is equal to Ia1 by Ia2 whole square. So the value of T1 is 900. Now this 900 has been increased to 1800, that is known as T2 1800. So that is equal to IN value is 100 by, I have to calculate the Ia2 value. So this is 1 by 2. So squaring on the both sides, I'll get Ia2 is equal to root 2 into 100, which is nothing but Ia2 is equal to 1. Actually root 2 is 1.414 into 100 will get around 141 amperes. So 141 amperes. As this is a series motor. See, if it's a shunt motor, what is the current? The same data, but take it as a DC shunt motor? So give the answer in the comment box. If it is a shunt motor, what is the magnitude of the current? Same data, torque T1 900 and T2 is 1800. So you find the value of the current and give the answer in the comment box. So thank you everyone.